Hello, Dalton. Yes, did I just get your message? You said if you are the first to join, I think you are the first. And it's so good to have you here. It's so great to have you join us, Dalton. It's great to have you. Okay, so earlier today, today, we indices and we looked at the laws of indices. We looked at the laws of indices. So yes, um, we looked at some examples on indices as well, and we really had a wonderful time looking at the topic indices. So we are going to continue from where we stopped in the last lesson we had on indices. Yeah. So I have some very interesting examples for every one of you who are joining us on this live stream. It's so good to have every one of you. If you can hear me, please type one in the comments. If you can hear me, type one in the comment. I've got some very interesting examples and exercise for us to get busy with and improve our competence on the topic indices. All right. So I am going to reiterate the law of indices where I talked about fractional index law, because most of the examples we'll be doing will be anchored on the fractional index law. I hope you can hear me. I hope that's clear. So let me come back and talk about the fractional index law. So fractional index. Two words here, fractional, from the word fraction, and then index, that's exponent, right? So let's say you have a raised to the power m over n. M over n is a fraction. M over n is a fraction, right? So we can say this is a fractional index. M is the exponent, m is the power, and n is the root. How would you know that? The numerator is the power, the denominator of the exponent is the root. So we can express this as what now? A raised to the nth root, because n here is the denominator. The nth root of a all raised to the power of m. Isn't that interesting? So this is how the fractional index law works. This is how the fractional index law works. So we're going to be doing some examples talking about this particular law of indices. So give me a second. Let me grab something. Okay, so who is the first person? Who is the first person to? Who is going to be the first person to like this life? No like yet. It's not too good. Please, let's like the life. Let's like the life. Thank you for that. All right, now to some examples. Number one. Simplify 1/4 all raised to the power of -1/2. Very interesting question. 1/4 all raised to the power of -1/2. Please, let's like the life. No like here. What's going on? People, what's going on? What's going on? What's going on? Let's like the life. Let's like the life. So look at the first example we have here under fractional index. Now, again, for those of you who, if this is the first time you are joining me on this topic, this is the second lesson I'm having on indices. After this lesson, after this live, kindly go back to the previous lesson I had on indices. There I talked about the laws of indices, and we also looked at some examples. So we talked about the negative index law. Let me say that again. We talked about the negative index law. See, we have a negative sign here, and for those of you who are not familiar with the negative index law, you might be deeply troubled when we start doing this. So let me just quickly walk you through the negative index law. So let's say you have a raised to the power of negative m. This negative sign here that's attached to the exponent, if you want to remove it, it's capable of taking the reciprocal. When I say reciprocal, it's like turning, it's like you, let's say you have a over 1. If you take the reciprocal of a over 1, it becomes 1 over a. So you are just flipping it. You have 2 over 3, you take the reciprocal of that, you have 3 over 2. All right. So it's a 1. It's like you multiplying it by its multiplicative inverse. Wait, did I say that right? Just see it as a fraction that is flipped over. That's how you do the what now? The negative index law. So this will become 1 over a raised to the power of m. Notice there's no negative sign here. This minus sign here has taken the reciprocal of a raised to the power of m. So hence you have this. Now I had to bring this because there's a negative sign here, which we will need the knowledge of the negative index law. If you don't know that law, you might not be able to solve this. So that brings us to this beautiful question, which says 1 over 4 raised to the power of negative 1 over 2. So first of all, let's get rid of that negative sign that is with the exponent. What do we do? If I remove that negative sign, I am going to take the reciprocal of 1 over 4. I'm going to take the reciprocal of what? 1 over 4. Does that make sense? So it's going to be 4 over 1, or just 4. Okay? Raised to the power of what? 1 over 2. Notice something. Negative sign is no longer here because we have taken the reciprocal of what? 1 over 4. Does that make sense? So now, 4 over 1 is the same thing as 4. So we have 4 raised to the power of what? 1 over 2. Now, like I told you, when I say if you have a fractional index, the numerator of that index is the power, while the denominator is the what? Root. So this can be written as what? As the square root, because this is 2. You can write 2 here or not. The square root of what? Of 4. You can just decide if you want, if you like, you can say all raised to the power of 1, but we don't have to do that because it will return the same result. So the square root of 4 is what? Is 2. So the answer we have to this question is just 2. If you have any question, drop it in the comments, and please let's like the live. Just one like. So 4 raised to half. Oh yes, 4 raised to half. Yes, Mr. Great Dog. Yes, 4 raised to half. That's correct. Yeah. Please let's like the live. Let's like the live. Let's share this live. And if this is your first time of joining me, this is Gpad Learn Math. My name is Gospel Adishi, and I'm a math teacher with over 10 years of experience teaching mathematics and further mathematics. All right. So I have a community on WhatsApp and on Telegram. If you want to join my community, you are welcome. Go to my bio on my YouTube channel. There's a link there. Once you click on that link, it will redirect you to my WhatsApp channel or my WhatsApp group or my Telegram channel. Any of them you want to join, you can join all. Some of them, or if you like, if you don't want to join any, it's all is the ball is your court. Okay. So why do you have to join my community? There you have access to information. When I go live, if there's a special offer, you will get to know. Okay? Excuse me. You will get to know when I go live and when I have special offer. One of the special offers I have is for people who are preparing for final exams. O-level exam, those getting into secondary school, those getting into a senior school. I have an exam prep, maths prep for them. So the class is already running from this month to April next year. You can get all the details on my website. The link again is in my bio, or you can send me a direct message. The link is on my bio to my WhatsApp. You send a message to me, and of course, we'll take it off from there. So let's go on. I think we are okay with this. Any question? If you have any question, please ask me as we move on. If you have any question, please ask. So I think we can look at another example. I have to clean this. I have to clean this. So I already explained this, and let's look at some examples. So number two, what do we have? Find the value of 8 raised to the power of negative 2 over 3. Very interesting, right? So we have a negative sign here as well with the exponent. And I told you what that does. It will take the reciprocal of the number. So this would be equal to what? 1 over, notice this was 8. If you like, you can say 8 over 1. But now we have 1 over 8. But what about the exponent? It's still there, 2 over 3. And I told you when you have a fractional index, the numerator, which is this one here, is the what? Power. Why the denominator is the what? So let me just say this is, of course, this is the power, and this is what? Root. So we do power, we do root. Now, this means the cube root, because of the 3 here, the cube root of 1 over 8, all the way to the power of what? The power, which is 2. Hope that makes sense. The cube root of 1 over 8 all the way to the power of 2. So this is equal to, who can tell me what's the cube root of 1 over 8? Who knows that? What's the cube root of 1? And what is the cube root of 8? If you know it, can you type that in the comments? What is the cube root of 1 and what is the cube root of 8? If you know it, type it in the comments. What is the cube root of 1 and what is the cube? Samuel, to me, yeah, thank you. Yeah, the cube root of 1 is 1 because 1 times 1 times 1 is 1. And the cube root of 8 is 2 because 2 times 2 is 4, 4 times 2 is 8. So that's 1 over 2. But we still have the power here, raised by 2. And we can distribute this 2 to 1 and 2 from the power of a quotient rule. We talked about this rule in the first lesson. Power of a quotient rule. That's why you need to go back to that first lesson and look at all those laws that we covered. So this can be written as 1 squared over 2 squared. And what is 1 squared? 1 times 1 is 1. 2 squared, 2 times 2 is what? 4. So men and women, the answer is what? 1 over 4. I hope this makes sense. Samuel, to me, thank you for the feedback. Please, let's like the live. If you have any question, any observation, any contribution, you are welcome to put it in the chat. I'm going to check it out and then also give you my feedback. I hope you're enjoying this lesson. If you are, please, let's like the live. Let's like. If this is valuable to you, like, share, comment. Okay, if you want me to move on to the next example, please type 1 in the comments. Type 1 in the comments. If you want me to move on to the next example, type 1 in the comments. Type 1, type 1. Type 1. Okay, so we have looked at 2 beautiful examples. Let's do some more. Let's do some more. Samuel to me, thank you. Okay, let's look at another example. This one says evaluate 0.008 raised to the power of 1 over 3. Okay, do you see this? Evaluate 0.008 raised to the power of 1 over 3. So how are we going to do this? How are we going to do this? See, do you know what I want to do? This 0.008, we are going to rewrite it as a fraction, as a common fraction. This is in decimal. we want to write it as a common fraction. So this is going to be 0.008 can be written as 8 over, see, this decimal point, if you want to move it out, it's like what we're trying to do is that we are multiplying this 0.008 by 1000. So let me just explain it here so you understand what I'm doing. So we have 0.008. And if we want to get rid of the decimal point, we have to multiply by 1000. But where is this 1000 coming from? You can't just manufacture 1000 and keep it there. You are distorting the value. So you have to create that balance. So since you are multiplying by 1000, you must also divide by 1000. Because when you cancel out like this, it returns the original number 0.008. So if you now multiply 0.008 by 1000, see 1, 2, 3, you have 1, 2, 3. It's just what? 8, right? Then over what? This 1000. So this is why if you have 0.008, you write it as 8 over 1000 from what I just explained here, okay? And all raised to the power of what? 1 over 3. How this is making sense? Hope this is beautiful, beautiful. Please, let's like the live. Thank you for those who have liked it already. And thanks for those who are supporting. Yeah, someone says 0.2. Okay. Can you express that as a fraction, as a common fraction? That's 0.2. All right, let's do that. Okay. So this is 8 over what? 1000. But we have 1 over 3 as the exponent. We are going to rewrite this as this 8 over 1000. The cube root. The cube root of what? 8 over 1000. You know why? See, this is the root, remember? So the cube root of 8 over 1000. And this becomes what? What is the cube root of 8? It is 2, because 2 times 2 times 2 is 8. So that's 2 over. What about the cube root of 1000? That's 10, because 10 times 10 times 10 is what? 1000. So this is 10 here. And if we want to simplify this, we don't want to write it as a decimal number. We want to simplify it in this form. So you do 2 into 2 is 1. 2 into 10 is what? 5. So what do we have? 1 over 5 as the final answer, or what you wrote as 0.2. Yeah, oh, I can see beautiful, wonderful feedback in the comment. Efras Shukri, Samuel Tumi, okay, that's awesome. Great job, everyone. Great job. You're doing a great job. Please, let's like the live so other people can join us. Okay. If you have any question, please ask. If you have any question, please ask me. If you have any question, please ask me. Let me take this off. So what I want you to do now, I want to drop a question. I'm still going to do it, but I want you to go first. So this is the question. Simplify -8 all the way to the power of what? 4 over 3. Okay, let me see who is going to do this. I want you to try this out and give me the answer. I have to go grab something really quick. Okay, who has tried it? Who has tried that question? Yes, look at the question. -8 all the way to the power of 4 over 3. Anybody? Anybody has tried this yet? Somebody says 16. Okay. Are you sure it's 16? Okay, I think you're right. See this. You know, this can be rewritten as what? As what? The cube root because this is, you have the denominator as 3. So the cube root of what? -8. All raised to the power of what? 4. And what is the cube root of -8? It means give me a number. When I multiply that number by itself 3 times, it will give me -8. So what's that number? It's -2, because -2 times -2 is 4, and 4 times -2 is -8. So the cube root of -8 is -2. Then with the power of 4. And what does this mean? It means that multiply -2 by itself 4 times. So now the trick here is really a tip. Since you have an even exponent, it's going to return a positive value, whether it's negative or positive. This is negative, but because we have an even, like 4, like 6, like 10, like 20, they are all even. If you have an even exponent like this, or index, it will always return a positive value. So the answer here is what? 16. Thank you for you, Efra Shukri, that said the answer is 16. All right, thank you. I think we can move on. Any questions so far based on what I've just done? So the first thing I did was to apply the fractional index law or rule, as I have it like this. Okay, and this is the cube root of what's -8, which is -2. Then I applied the power of 4 here, which is what? 16. I hope that's okay. So we have done 4 beautiful examples. Let's keep going. Number 5, simplify 125 raised to the power of -2/3 times 15. So again, I'm going to wait maybe for a minute or two for you to try this one. Okay, try it out. 125 raised to the power of -2/3 times 15. Who is going to try it out? Yes. I am waiting. Give this a shot. So again, use the fractional index law, because there you have a fraction, but again, you have a negative sign here. So you know what to do with that negative sign, like I told you before. You know what to do, right? Okay. So if you know what to do, why not do it? Somebody has got the answer. He said 3/5. Okay, he said 3/5. Let's see if that is right. Let's see if the answer is truly 3/5. So 125, see, because you have this negative sign, it's going to be 1/125. The cube root, the cube root of what? 125. The cube root, because you have the fractional index has a denominator of 3. So the cube root of 125 all the way to the power of what? 2. Where is it coming from? The numerator here, this one here. That's the power, and this is the what? Root. Is that okay? So times 15. Let's keep going. So this is going to be 1 over. What is the cube root of 125? That's 5, because 5 times 5 times 5 is 125. So that's 5 squared. The squared from here times what? 15. See that? So what would this be? That would be 1 over. What is 5 squared? 5 times 5. That's 25. But we have times 15 here. You can write over 1 if you like. And then we simplify. We divide 15 and 25 by 5. So 5 here is 3. 5 divides 25, you have 5. So what's your final answer? 3/5. I hope I'm right with this. Yeah, anybody? Okay, yeah. 3/5 is the correct answer. 3/5 is the correct answer. 3/5 is the correct answer. Please, let's like the life. Let us like the life. Let us like the life. Okay. All right, let's move on. Number 6, we have 1/16 all raised to the power of -3/4 plus 5 in bracket 9 raised to the power of 0. Now, if you are here and you need one-on-one lessons, I also do that too. You need one-on-one. Maybe you are preparing for an exam, ASVAB, GCSE, IGCSE, whatever it is, JAM, WASC, NECO. If you need me one-on-one, I do that as well. Okay, so I have one-on-one classes. I also have group classes for those who are preparing for specific exams. I am your go-to person. Okay, I am your go-to person. Now look at this question. It says 1/16 in bracket raised to the power of -3/4 plus 5. Then in bracket we have 9 raised to the power of 0. First thing first. Let me just even say this first. Whenever you have, if you have a non-zero number, non-zero number raised to the power of 0, it becomes what? 5. If you have 9 raised to the power of 0, that's so it becomes 1, rather 1. 20 raised to the power of 0 is 1. 500 raised to the power of 0 is 1. However, 0, because this is 0, raised to the power of 0 is not 1. Please take note of this. 0 raised to the power of 0 is not 1. Okay, somebody has already given me the answer. Isn't that beautiful? So see, this negative sign will take the reciprocal of 1/16, giving you what? Just 16. So this is going to be what? 16, all right? Raised to the power of 3/4 plus 5. See this, 9 raised to the power of 0 is 1, and 1 times 5 is also 5. Hope that's clear. So here we have what? The fourth root. Why? Because this is the denominator of the fractional index. So the fourth root of 16 raised to the power of 3, then plus 5. Are you getting it? So what's the fourth root of 16? Give me a number. When I multiply it by itself 4 times, I will get 16. What is that number? 2, because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is what? 16. So that's 2 raised to the power of 3 plus 5. So what is 2 raised to the power of 3? 2 times 2 is 4, times 2 is 8. So you have 8 and plus 5. What is 8 plus 5? 13. Somebody has already gotten the answer. 13. Oh, yes. The answer is what? 13. That is awesome. Great job, guys. Great job, guys. You're all doing very well. You're doing very well. So if you have any question, you can ask your question. If you have any question, please ask your question. Ask. If you have any question, ask. Okay, so I want you to try this one. This is an exercise for you. Here is an exercise for you. Exercise. Just one question, just one. Evaluate. Two divided by 64 over 125 raised to the power of -2/3. Yeah, so here's the question for you to try. Give me a check. When are you taking logarithm? Logarithm should come after indices, but if you want detailed lessons, If you want something that will be much more impactful than what I'm doing here, join my paid class. Join my paid class to have a better experience. This is just me scratching the surface. It's deeper if you join my paid class. But naturally, logarithm comes after indices. So if you stick long enough, I might be able to do that. You might be able to experience me taking logarithms after indices. I hope that answered your question. Artificial. Okay. How many of you are already doing this? So I will not just stay here and wait in vain. If you are doing it, just type one in the comment. If you want me to hold on and you're already doing it, type one in the comment. You are doing it and you want me to hold on, type one in the comment. Please, those of you that have not liked the live here, please let's like it. Somebody has already dropped the answer. Okay, cool. One. You said one. Okay. You are typing one because you're already doing it. Okay, good. So if I say one, you can just type just one. Okay, you don't have to write ONE. I know it's much easier typing one like this rather than this. So unless you like ONE, but it's fine too. Okay, yeah. Okay, this is a beautiful. Somebody give me the answer now. He said 322532 over 25. Oh, is that too large? Are you sure that's right? Anyways, I won't know yet until we have done it together. So let's wait for other people to give us their answer. Let's wait for them. Let them give us the answer. Okay, 32 over 25. Okay. I think somebody else got this. Efra Shukri. Yeah, Efra Shukri. Yes, you were in this. You were here when what am I teaching? Indices, like power rules, exponents. Yeah, indices. As you can see here, fractional index. So the examples we are considering are majorly under you are going to be applying the fractional index rule, but the broad topic is indices. Indices, okay? Yeah. Oh, good to have you. Femi Bukola, great to have you. Good to have you here. Please, let's like the live. Let us like the live. Okay, I think I'm going to do this so those who cannot do it will learn from the correction. So let's start. 2 is a very simple, easygoing, beautiful number. But you see these guys, we have to dismantle them. So what do we do now? I'll just write 2 like this, divided by. Let's come here. I told you, if you want to remove this negative sign from the exponent, you have to take the reciprocal of this number. So what it is? It's very easy. Just simply do 125 over 64. Then 2 over 3 as the exponent. Notice the negative sign has gone, but when it did a little damage. What did it do? It upset these guys here. What was down went up, what was up went down. You see how powerful the negative sign is. Okay? So now we have 2 divided by. Remember, this fractional index, the denominator is the root, the numerator is the power. So it's going to be 125 over 64. That's the cube root. You see this? And then all raised to the power of what? 2. Because of this power 2 here. So this is equal to 2 divided by, what is the cube root of 125? It is 5. Because 5 times 5 times 5 is 125. So that's 5 over. What about 64? The cube root of 64 is 4. 4 times 4 is 16. 16 times 4 is 64. So that's what? 4. Remember, all raised to the power of what? 2. Are you still with me? So this is equal to, maybe I should just come here and wrap it up here. So this is equal to 2 divided by, see, you can distribute this power 2 to 5 and 4. That's the power of a quotient rule. We talked about this in the first lesson we had on indices. That's 5 raised to the power of 2 divided by 4 raised to the power of 2. I just distributed the exponent outside to both the numbers 5 and 4. So this is equal to 2 divided by, what is 5 raised to the power of 2? 25. And what about 4 raised to the power of 2 is what? It's what? It is 16. So this becomes 2. If you change division to multiplication, you have to flip this fraction, turn it upside down. So you have 16 here over what? 25. And you can write 2 as 2 over 1. Excuse me. 2 times 16 is what? 32. And 1 times 25 is 25. So you can just write it as a mixed number, which is one whole number. Is that not 7 over 25? I hope that's right. Anybody with that? 25 over 8 is the answer. Over 8. How is it over 8? Please, let's check very well. The cube root of 64 is 4, right? And then you square it. 5 squared over 4 squared. 25, times. Yeah. Are you sure of what you just said now? If I'm not wrong, this is 4. Yeah, this is. Please, what's going on here? Anybody with the answer? Yeah. I'm waiting for you, bro. 32 over 25. Yeah, this is the correct answer, okay? Yeah, very easy though. Yeah, it's easy, Shane is okay. So yes, I hope you understood everything I did. We've gotten the answer. One whole number 7 over 25. One whole number 7 over 25. Any question? If you do have questions, please ask me right now. Anybody? Okay, somebody said prove a raised to the power of 0 is 1. Yeah, we talked about the laws of indices. Earlier. So you go and watch that video. Or was it that asked that question the other time? We've already talked about the laws of indices. If you want to get familiar with the laws of indices, it's still on my channel. Go there and watch the first lesson on this topic. Yeah. So I hope you have learned from what I've done so far. For those of you who didn't do it or who got a wrong answer, please learn and take correction from what I've done. Okay. So what we want to do now, it's an ability to be able to change a number and express it as a base of something else. Let me give you an example. So let's say you have 8, for instance, and you want to express it as a power of 2. You want to express it as a power of 2. You can do that. You can simply write 8 is equal to what? 2 raised to the power of what? 3. So the examples we'll be considering would require us to have knowledge of changing the base, expressing the number as a power of another. All right. So 8 is equal to 2 raised to the power of 3. All right. Yeah. So let's look at some examples on this. But I'll write the instruction here first. You can write without using mathematical tables. Without using mathematical tables or calculator. So the first one we have here is this. Let's simplify 16 raised to the power of 1 over 2 times 8 raised to the power of -4 times 3 raised to the power of -2 over 3. This is quite long. I hope you got that. 1, 2, 3, 4. Yeah. Are we ready for this? Are we ready? Oh, it seems some part is cutting off. Okay, so let's begin. Now, I want you to observe something critically. This is 16. This is 8. Can they have a unified base? So you can apply the multiplication law of indices. What about 3 and 81? Can we express 81 as a power of 3? Yes, we can. So for 16 and 8, we can express both of them as a power of 2. So let's start with 16. I can rewrite 16 as 2 raised to the power of what? 4. Remember, we are still using it to multiply 1 over 2 here because that's the already existing exponent. So we'll do the same thing with this 8. Express 8 as 2 raised to the power of 3. You see that? Then what? Negative 4. So here times, this is 3 raised to the power of what? Negative 2 over 3 divided by, what about this? 81 is what? 3 raised to the power of 3. We have negative 2 over 3. Are you with me? So let's come here. This is 4 times, from the power of a power rule. We talked about this in the first lesson. Power of a power rule. That's 4 times 1 over 2. They are both powers, so you multiply them. 4 times half is 2. 4 times 1 over 2. 2 here is 2, so that's 2. So this will become 2 raised to the power of what? 2. Easy. So times, what about this one? Again, you multiply 3 and negative 4. That would be 2 raised to the power of what? Negative 12. Are you with me? Are you with me? So times, what about this one? Nothing is going to change there. However, when we come here, see this now, 3 cancels 3. See, you have 3 times negative 2 over 3. You cancel that, you have what? Just negative 2 left. Make sense? Okay, good. So let's go on. We're getting somewhere with this, right? So this is equal to, see, they have the same base. We're going to apply the multiplication law of indices. You will add the exponent. So 2 plus, well, this is negative 12. We can just wrap it in a bracket. See that? We come here and we do the same thing here, times 3. This is negative 2 over 3. Now, this is the division law of indices. So because we are dividing and they have the same base, we will now subtract the exponent, but this is negative 2. So be careful with what you write there. The minus is because of this division, and negative 2 is from negative 2 here. Answer it, please, after solving your current one. What's going on here? Okay, so this is equal to 2. This is plus minus is minus. So 2 minus 12 is minus 10. Yeah. Times 3. What about this? This is minus 2 over 3. Minus become over plus. You can write over 1 here. So this is equal to, you see, there's a negative sign here. We can take the reciprocal of that. So that will be 1 over 2 raised to the power of 10 times, what about this one? So let's quickly work this out. This is the LCM of 3 and 1 is 3. 3 into 3 is 1. 1 times negative 2 is negative 2. Plus 1 into 3 is 3. 3 times 2 is 6. So what do we have? What is negative 2 plus 6? That is 4. So 4 over 3. So what I have here is times 3 raised to the power of what? 4 over 3. Are you with me? Okay, so this becomes what? 1 over 2 raised to the power of 10 is what? Okay, I think we might have to leave it somewhere around this. I'm trying to see how this can be simplified. And I even want to believe that everything is okay here. Let me check. There's a mistake here, and nobody even told me that. This 81 is meant to be 4. Oh my goodness. 3 raised to the power of 4 is 81, not 3. I knew it. There's something up somewhere. This is supposed to be 3 as well. This is not right. So this is supposed to be negative 8 over 3. So I have to change this. I hope you people are with me, or you're just sleeping. This is what? Negative, then we have what? Negative 8 over 3. Yeah, I hope everything is in order now. So what else? We need to change this one as well. Let's change all of this. Let's change these guys here. So you see, it's important you cross-check your work. So this is 3 raised to the power of this is minus 2 over 3. Minus is plus. So 8 over 3. Making sense. So the LCM is 3, the same. So minus 2 plus 8 is what? That's what? 6. Minus 2 plus 8 is 6. Yeah, when you do 6 divided by 3, you get what? 2. So this will become 1 over 2 raised to the power of 10 times 3 raised to the power of 2, because 6 divided by 3 is 2. Finally, your answer will become 1 over, what is 2 raised to the power of 10? Who can tell me? What is 2 raised to the power of 10? Who knows it? Type it in the comment. 2 raised to the power of 10 is what? Somebody type it in the comment. Yes, anybody? What is 2 raised to the power of 10? Anybody? 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 2 raised to the power of 10 is what? Nobody's here? Bam, 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 na, na, na. Anybody? 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 Okay, it's 1024. Then times 3 raised to the power of 3 is 9. So finally, you have 1 times 9 is 9, then over 1024. So men and women, this is your answer, 9 over 1024. Your final answer is 9 over 1024. This is your final answer. Let me make this nice and neat. Just wrap it up like this. 9 over 1024. So I think, irony guy, yes, that's it. Okay, I think we're going to stop here. Maybe I should just do one more. And yeah, I'll just do one more. And tomorrow we'll continue from here. Let's do one more. Yeah, let's do one more. Let's do one more. Let's do one more. Let's do one more. Okay? Good. So let me give you a few seconds to take a screenshot of what I have here. So you see, just one mistake here cost us a lot. In fact, if I did not discover that mistake, it would have been very terrible. So that's why you need to always check your working. Anytime you're solving a problem. Can you see me? Are you talking to me, or who are you talking to? When you said, "Can I see you?" What do you mean by that? Is it me you're talking to, or who? Okay, so let's just do one more under this. Evaluate 9. Is that it? Yeah, that's it. 9 raised to the power of 1 over 2 times 27 raised to the power of 2 over 3, or divided by 64 raised to the power of 2 over 3. Yeah, by now, I think we can even run with this already. This is already appearing easy, because if you are familiar with the laws of indices, then this will become very interesting and easy for you. So let's begin. 9 raised to the power of 1 over 2. What is that? That's the square root of 9. So this is the square root of 9 because of the exponent of half, times, what about this? 27. This is the cube root of 27, all the way to the power of what? 2. You see that 2 there? Yeah. So all divided by what? This is the cube root of 64, all the way to the power of what? 2. Still using the laws of indices, the fractional index law, and all that. So what is the square root of 9? That's 3. So you write 3 times, what is the cube root of 27? That's 3. And 3 raised to the power of 2 is what? 9. Oh, yes. So you come in. What is the cube root of 64? That's 4. 4 times 4 is 16, times 4 is 64. So 4 raised to the power of 2. So finally, you have 3 times 9, which is what? 27, over what is 4 raised to the power of 2? That is 16. So finally, this is equal to, how many times will 16 go to 27? To go one time with a remainder of what? 11, then over 16. Yeah, that's your final answer. That's your final answer. So you see, I just used the fractional law of indices. Then I think that was the only thing I really used. Then I just divided. You already know this basic rule of dividing fractions, and that was all. So we are going to end the lesson here. See, tomorrow is Saturday, West Africa time. I think I will be targeting 1 p.m. I should try to come live tomorrow by 1 p.m. We have so many very interesting examples that we have to do. We have to talk about algebra, factorizing algebra problems with indices, then initial equations, initial equations, or what problems leading to quadratic equation, simultaneous equation, and all that. So it's actually a broad topic, which, no, I don't use the word broad, but an interesting topic, which has so many other beautiful applications and areas that would be very, very useful if you stick to the end of this lecture series on indices. It's going to be really, really fun and impactful. So I'll be coming live more often, but I still have my paid class, and it's even much more impactful than this, and it's very, very affordable. All right. Just about $40 for 6 months. So you see, very affordable. If you're interested, there's a link on my bio. You click the link, you'll be redirected to my WhatsApp DM or the website where you can make a purchase. You can also join my WhatsApp community, my Telegram channel, my WhatsApp channel. It's all free. Go there. You'll be firstly informed when I want to come live. And at times, I also give enough room for people to prepare when I come live. Or if there is any special offer that I have for my students, I put it out there in my WhatsApp channel and other community. So do well to join my community. I hope to be live tomorrow again by 1 p.m. West Africa time. Thank you for the 13 of you who stayed to the end of this lesson. Hope to see you all tomorrow. It's bye for now. I hope if you have any question, maybe I should just wait for 1 minute. Let's see if you have any question. Maybe you want to ask me about something, about the offer, about my community, about anything at all, about what we've done so far. You can drop it in the comments. I'll be checking my chat to see if you have any message for me. Cool, Leop. Thank you. Irony guy said he answered it. Okay, that's good. Yeah, irony guy is 27/16. Yes, as you can see. And then we also wrote it as a mixed fraction. How can I connect to you? Oh, yes. So here's how you can connect to me. You can, if see, you know what? If you are having difficulty trying to locate my bio on YouTube, maybe you cannot, for whatever reason, you could not locate the link on my bio. You can send a WhatsApp message. Here is it: +234 8073. No, sorry, not 73. I'm giving you another number. So +234 7048 370 375. So this is my WhatsApp number. You can send me a direct message here if you cannot locate the link on my bio. But the link also has my WhatsApp, that once you click on that button, it will redirect you to my WhatsApp DM. Or you can just send a message. This is my WhatsApp number as well. This is how you can connect. This is how you can connect with me on WhatsApp. Or you can search Gpad Lemmat on Instagram and send me a DM on Instagram. When I go there, I will see your message, and of course, we'll take it up from there. So these are ways you can reach out to me. My Instagram DM, still Gpad Lemmat. See that, Gpad Lemmat? Or yeah, just search Gpad Lemmat on Instagram. I'm very active there too. I want to believe I'm active there. Or this is my WhatsApp number, or check my bio. There's a link there where you can reach out to me. So that's how you can connect with me. Yeah, Arinike, I said good to have you. So by tomorrow, hopefully around 1 p.m. West Africa time, I should try to be live. Yeah. And if you are from the UK or from the US or from Canada, I have another YouTube channel. It's maths with Gpad. You know, this is Gpad Learn Maths. That's maths with Gpad. So there I cover questions on SAT, on GCSE, IGCSE, ASVAB. So you can go there. There are many questions there. There are many videos that have covered questions on these exams, foreign exams. You can go there and just enjoy the videos that are there, both short and long videos. And I also intend to do more. I also intend to go live on that channel as well. But if you want to know when I go live, the link is always there for you to join my community. I think it is time to say bye-bye. Thank you, all of you, for staying through. Hope to see you tomorrow. If you have any question, please drop it. I will just step out and then still check my chat. Yeah, if I see anything that I have to respond to, I'll come back here. But if not, I will just disconnect behind the scene, and that'll be all for tonight, or maybe today, depending on where you're watching from. Okay, thank you. You have a wonderful evening or night or day. Bye-bye.